Hello and welcome. I'm back here with Micah today. Micah has returned from adventures
Good to be
offline,
back.
so glad to have you back. Yeah, we're gonna do the normal. Kick this off with some news in the OAuth world and take questions in the chat. So if you are joining us live, welcome, and if you're joining us after the fact, also welcome. And we'll still answer questions in the comments. But if you are live, go ahead and say something in the chat so we know you're here, and feel free to drop in questions at any point. So yeah, let's quickly recap since Mike has been gone for a while. So we'll
What I
try
missed.
to. Yeah, missed a lot. It's been a busy month. We had a bunch of working group meetings spread out over the course of the month. Since this was the month of IETF 109, which would have been in Bangkok, and I was very much looking forward to going there, and that did not happen this year. But instead, it means that I get to spend more time with my cat. And the meetings, we did the same thing again this time around, where instead of trying to cram all the topics into a single or two-hour sessions at the IETF meeting, we instead just had a bunch of interim meetings spread out over the course of several weeks. And the last one in that series is actually next Monday. So yeah, I had a bunch of topics to cover. Looking through the list here, we had a meeting about Web ID, which is a proposal from Google to integrate identity deeper into the browser. So there's some interesting discussions going on there. There was a meeting for the new group. Actually, that was at the IETF during the IETF session, but that's the GNAP group. And there was also a meeting just the other day on Monday about Depop, which is, I think we've talked about it a little bit before,
Yes.
but that's a spec for signing requests so that access tokens can't be used if they're stolen. And the difference with that spec compared to other attempts at similar things is this happens at the application layer. So it's actually the application code creating the signature, putting it into a header, and then as opposed to like mutual TLS, which is another way of doing the same kind of thing, but that happens outside of the application. That's in the client library, the TLS client. I think that's about it.
How is
Oh, there was
Depop progressing?
yeah. So that is it is slowly progressing. I would say the discussions were around discussions this last meeting were around things like um, is it actually protecting the right stuff? Is it properly protecting it against replay attacks? Um, so yeah, it's still in progress, and I think it still has a way to go before I would consider it stable. Um, but yeah, I feel like sometimes these meetings don't go quite as they aren't quite as productive as they could be because a lot of the time you have to kind of catch people up on what the spec is in the first place, and if it's only a 1 hour meeting, you have to do a lot of that catch up and then have a discussion, and then sometimes people can sort of derail a discussion as well, right? If like someone's just focusing on too much of a particular point that may not be relevant, or at least isn't the goal. So I guess that's why this work continues on the mailing list as well. In the meantime,
Right. Are there any practical applications or experimentations of Depop currently that you're aware of? If I, as a tinkerer, wanted to see Depop in action, is there somewhere I could go beyond the spec to see an example that you're aware of, or to drop some code in somewhere?
yeah, good question. I know there are some. I know like as people are working on the spec, it is being built somewhere. I'm not sure I
Right.
actually know where
Hmm.
that is actually being built. So I don't know if it's just internal implementations of people's own stuff or if it's turn into libraries at all.
Yeah. All right. Well, maybe I'll take that as a takeaway for next time. See if I can poke around and maybe there are a bunch of authorization servers out there. Spring Boot has one, Keycloak has one.
Right.
That's just the Java world. I'm sure there's others, but they're all extensible. So it'd be interesting to, try to implement one of these emerging things and as an exercise and see what kind of snags you run into or how hard or
Definitely.
easy it is.
Definitely. That's the kind of feedback that's super appreciated as well, because it's one thing to just sort of come up with theories about how specs should work, and it's another to actually turn it into practice. So,
All right, I'll add it to the
yeah,
list.
that'd be
I think
super
we need
cool.
to do that for macarons too.
Hmm. One of the things I'm really interested to see, if it's possible, it should be possible, but see how easy it is to use the browser's um, crypto APIs that let the browser generate a private key and sign stuff. So there's I forget the name of it now. It's one of the web crypto set, but it's an API that the browser can use to generate a private key, and then the key isn't actually able to be extracted. So
Hmm.
the browser can then use the key to sign stuff, but you can
Hmm.
never actually get the key itself. So,
Yeah, so JavaScript doesn't have access to it. Nothing has access
yep,
to it. Great.
exactly. Cryptokey API
Hmm.
is the name of it. And that is, yeah, I'm really interested to see if it's possible, or rather how easy it is to use the Cryptokey API with Depop, because that would kind of be the best way to do it, right?
Right. Yeah.
You're of course still possibly vulnerable to cross-site scripting attacks, in that a cross-site scripting attack would let the attacker create a signature, but you at least wouldn't be able to have the attacker steal the key.
Right. Yeah, I'm
So
looking
yeah,
on
this is
the Mozilla page. It looks like it's compatible already with most of the major browsers, excepting Safari and Internet Explorer. No surprises
yeah,
there.
no surprises there. But yeah, this property extractable is the one, is the
Mm,
key. So you can say generate a key and then make it not extractable. Um,
nice.
yeah, it's implemented in a surprising amount of browsers, except or where's the specific one? This one, um, except for IE 11 or any IE. So I guess it probably will never be added to that because all the new work is happening in Edge.
Right.
And then Safari does not support it yet. I'm guessing because everybody else does, they're going to eventually just add it. But they don't tend to share much of a roadmap, right?
Yeah.
But at the very least, I think it'd be a pretty cool demonstration of the concept of using a private key that can't be extracted in order to actually sign stuff in a browser, because you can do that on a lot of other platforms.
Yeah, very cool.
Yeah. Um, yeah. So that's the Depop world. Oh, there is a new spec that I can't remember if I think we didn't talk about it yet. I think I mentioned it in like last week's or something. But new spec was brought up to the group called um, it's called Authorization Server Issuer in authors Authorization Server Issuer Identifier in Authorization Response. It's a mouthful.
Hmm.
Um, the the interesting thing about this one is that so it only is necessary in a specific case. Really, it's necessary if a client is configured to work with multiple authorization servers.
Hmm.
So if that's the case, the problem is that when the client gets redirected, when the authorization server redirects back to the client, there's an authorization code in the query string, right? And state. And the because this is a front channel message, there's no indication of where it came from. There's no way to actually tell. And if there are multiple authorization servers, then there's this mix-up possibility where the the client may be tricked into sending the authorization code to somewhere else. If you just like the authorization code injection attack that you were demonstrating,
Right.
same idea, but it's tricking the client into sending the authorization code somewhere else to a malicious authorization server or whatever it is. So what this parameter does, it basically adds one parameter into the redirect. Example, authorization response. So, oh gosh, why is that flickering? Let me share my whole screen instead of the window. I think that might help. So instead of redirecting back with just the code and the state, there's now a new parameter, ISS, with the identifier of the authorization server. So the theory there is that this prevents that mix-up attack because
Does it say
the
the client
client,
must use that issuer to exchange the code or something?
yeah, it's clients that support this must extract the ISS from the response. Yep. Compare it to the identifier of the authorization server where the request was sent to. So it assumes that the client can keep track of where it made the request, which it has to in order to use Pixie and things like that. So it knows, the client knows the server it went to, it started talking to, and then if this has to come back matching, and oh gosh, now this was my question on the call, which they answered, and then I've forgotten. The reason that this is not able to be forged.
Yeah, that was going to be my next question for my
Yeah,
naughty browser extension. Why not just replace the issuer parameter?
it's there was a oh my gosh, there was a reason for it. There was a reason that it worked, and let me see if it's in the. Where was this brought up? Where was this brought up? Because we have a meeting about it coming up. Oh, I think it was in this meeting. I'm gonna have to find the minutes from that. I didn't link them in here. I'll find the minutes from that because they described it well, about why that actually works, and it's not obvious.
Yeah.
Yeah. Yeah, I'm gonna have to read that. Okay, so we have some questions in the chat. Should we, since I apparently
Yeah.
can't remember the details of how this mechanism works, should we move over to the chat questions?
Yeah, sure. And I have a little demo later, so maybe
Yeah.
we'll it'll bubble up while we go through that. But sure, let's take a look.
Okay, let's see. After you use a refresh token and exchange it for a new access token, and refresh token should the old refresh token still be valid for a couple of seconds? Our custom OAuth server doesn't support that, but some integrations require it. Is there a standard? That is a good question. So the story here is that there's multiple ways to handle it, and for if you're talking about confidential clients that have a client secret, then you don't really need to change the refresh token when it's used. Like it doesn't really solve anything. So keeping the refresh token the same is fine. If you're talking about public clients that don't have any credentials, then the recommendation is to change the refresh token every time it's used. However, you end up with this sort of this situation where The risk is if there's a network glitch or some other fault that causes the application to send the refresh token twice, or not because it didn't recognize the first one went through, that could then cause a problem. So people are generally building in some amount of fuzziness to compensate for that. The place this is documented, though, is in the security best current practice. So if you go over to security best current practice, this document is where all that kind of stuff lives. So let's see, this was last updated. Okay, so this has most of the recent stuff. Token replay prevention, I think it's here. Refresh tokens must be sender constrained, which means some sort of binding with a credential or rotation. And this is the place to go to look for that kind of stuff. The so let's see. This is refresh token rotation. Here's the implementation note. So, okay, it looks like it didn't make it into here, but yeah, the concern is about that sort of, should you keep it valid for a couple of seconds? And there's trade-offs there, because what you're trying to do is prevent double use of a refresh token, and ideally, in a perfect world, it would be actually just one time strict. And then the problem is that nothing is a perfect world, right? So you end up with having to decide your risk tolerance for that window. So do you want to give it a couple seconds of fuzz to allow for network glitches at the cost of then risking malicious double use within that time window?
Yeah, and also for in the sender constrained use case, the refresh token has its own expiration anyway. So that kind of alleviates that question of, will it be valid for a couple seconds? It's going to be valid for as long as its uh, expiration dictates, and once it's expired, you'll have to re-authenticate.
Yep. Yep.
That
Good
is,
question, though.
I wonder if anybody is trying to, do some kind of, classic uh, async coordination like semaphores or something like that to have one-time use refresh tokens in an async world, as opposed to, I guess that would be the other approach, rather
Mm-hmm.
than having some sort of drift, having some sort of coordination, which could potentially, slow down your pretty async or parallel system.
Would you have to do anything different at the protocol layer, or could you do it by like embedding where the authorization server can just embed stuff in the refresh token itself? How does that work? How would that actually work?
Well, I guess, I mean, Okta doesn't, but there are providers that use GWTs for refresh tokens. So that might afford you the ability to do something like that. But I was just thinking you might have a system where the system would know if a particular refresh token had been used or not. And like maybe you request of some service, like give me the refresh token so I can go get a new access token. And then like anything else that requests the refresh token is blocked until there's like a new refresh token to be used.
Mm. Hmm.
But, these are classic like scheduling and timing things, like deep in the code of, Unix subsystems where they're using like semaphores and all kinds of like sophisticated algorithms to manage, like fair timing and things like that. So maybe more trouble than it's worth.
Yeah. Yeah. Interesting. Well, let's move on to this other question, which is a great question from Andreas. As mentioned in some of your videos, the implicit flow shouldn't be used to get access tokens as it's considered insecure. Question is, can it still be used to get ID tokens for OpenID Connect, or should we also try to get rid of that? Very good question. So the thing that is the risk is that stuff sent in the front channel, which is what the implicit flow does, might be stolen. And I've started using this analogy of the front channel being a package delivery service. So if I wanted to send you something in the front channel, it's like using a package delivery service, like putting it in the mail. So if I put an access token in the mail, put it in an envelope, put a stamp on it, it'll probably get there. It'll probably be fine. But as the sender, I never actually really know for sure. I don't know if it's been delivered, and I don't know if it's been opened up in the mail, right? All that's possible. It could even still get to the destination and have been opened up and resealed. I would never know, right? Same problem on the receiving end. You don't actually know where it's from. It might have a return address, but that doesn't really mean anything. So using the front channel is like handing it off to a package delivery service. So for the implicit flow with access tokens, the problem is that the access token was then sent in the mail. So if you mailed somebody a key to your house, would you trust that key anymore, right? Like anybody could have copied it along the way, even if it did make it. And that's a pretty big risk because the access token can do a lot of things. It can read data, it can read a lot of data, it can even potentially modify data. So that's the main risk there. Now, those are all the reasons that like we're deprecating the implicit flow in OAuth because it doesn't serve any purpose and it sends the access token in the front channel. Now, for OpenID Connect, for ID tokens, the risk is still there, right? The problem with OpenID Connect using the front channel is that the ID token might be stolen if it's sent in the front channel. The difference is what happens when the ID token is stolen. So if someone steals an access token, they can go use it at an API. If somebody steals an ID token, what can they do with it? Well, they can read it. They can see what's in it. And that might be bad and it might not be bad, depending on how you're using this. So if you've packed in a whole bunch of information into your ID tokens, like details about the user, like their mailing address or their I don't know, any kind of sensitive information, if that's in your ID tokens and that's stolen, that's bad. And then you would not want to use the implicit flow with OpenID Connect because that risk of that data leaking is too high. If the only thing in your ID tokens is the subject identifier and then all the ID token crap, like timestamps and whatever, then maybe it's not the end of the world if that's stolen. It's certainly not great, but it's probably maybe that is within your risk tolerance, right? So it's up to you to decide your risk tolerance there, but it's going to heavily depend on what's in the ID tokens themselves, because the risk of them being stolen is still there with OpenID Connect.
I'd also add to that, as a developer, there's kind of a more subtle issue, and again, this is my opinion, but I don't want to be responsible for deciding, all right, in this context, I'm going to use implicit flow. In this context, I'm going to use Pixie. As just for me personally, as a developer and other developers, that I might be managing or part of a team, I'd rather have, kind of one approach to rule them all, and not have to, it's a little bit like having the application have to rely on checking a nonce or something. I wonder what percentage of applications actually check the nonce. It would probably be startling if we ever could get a real number on that. So I would much prefer to say this is the best practice. So if we need an ID token, great, we can get it. Use Pixie.
Yep. And chances are you probably need both. Like there are a few times when you only need an ID token, but chances are you're probably going to need an access token also, in which case just get them both from the back channel using Pixie.
Yeah, it's a good question though.
But it's a good question.
And it's one of the reasons in the implicit flow detector browser extension that we talked about in previous OAuth happy hour editions, if you do find a site that's passing an ID token through the front channel, it shows up as a little yellow flag. Whereas if it's a access token, it shows up as a red flag, just to kind of indicate there is a subtle difference. It's not as big an issue, but it's still leaking data that you probably don't want to leak. Could be personal information jammed into that ID token.
Yep. Well, cool. Do you want to show off the new tool?
Yeah, sure. So this is a work in progress, little caveats right up front, but we kind of soft launched a new token site called token.dev. Right now it's just focused on JWTs, but the intention is to show off and have it be a learning place for a bunch of different token formats. And the very next one is going to be Paceto that we show off next. But for right now, I'll show you this, and this isn't it yet. I'll show you token.dev. Where I'm at now is I just want to quickly grab an access token. I'll post this in the chat also for anybody that's interested. But I wanted to have an access token handy, just to show off some of the cool features of what you can do with token dev here. So token.dev, it's a top level domain. And you've probably seen interfaces similar to this before, but there are a couple of interesting things about this particular example that we're building out here. So right now, as I said, it's focused on JWTs. You come here, it's got an example of a JWT string. It automatically generates a signing key for this particular algorithm. This signing key is the proper length for that algorithm. And you can, add some other parameters here, and it will repackage it with that same signing key. When you start to get into the more sophisticated algorithms with JWT, like you choose one of the RSA ones, it's using a fixed key pair here. This is all client side. We wanted to make sure that we were being responsible and not doing things like passing around private keys over the wire anywhere. So this is all client side. And one of the things we need to add here is just like some little informational text saying like, please don't use this private key anywhere else because it's fixed. Every time you come here, it's going to be the same private key. It's all client side. But it is actually using that private key to sign the JWT and the public key to validate it. The thing that I think is most interesting about it, if I now go and grab this access token that was issued by Okta and pop it in here. So signature, we can see the payload, but signature verification failed, which is expected because this public key doesn't match the private key that was used to sign this JWT. And in fact, nobody has access to that private key because that's just, a line that Okta draws. Even if it's your Okta org, you don't have access to that private key. But it does support using JWKS URIs. And that's a feature where you can get a JWT key set link where it will pull down a public key. So it's still giving me an error here because this is not the right JWKS endpoint. But let's see, I think I still do have that JWKS endpoint in here somewhere. There we go. And now what it's done behind the scenes is it's made a network request of this URL, which I can show over here. So this is just the public key set. It's meant to be public. You can see there's two of them because of how Okta manages key rotation. And so it's using, first of all, it's going to grab those public keys, and then it's using the key ID found in the header of this JWT to verify the signature on it. and it shows up as verified. So that's kind of cool. It's something that Okta supports. Any service provider that supports OIDC discovery would also have a JWKS or a well-known endpoint where you could then get a JWKS endpoint. So there's still more work to do on this site, but I'm kind of excited about the uh, the ability to tinker around and to use a remote public key URL to validate an access token. So if you have an access token that you've intercepted or using or found in the wild, and you know that that service provider also has a JWKS endpoint, you should be able to pop it in here and validate it. Um, Last thing I'll add for now is just if I go in here now and start making changes, validation is going to fail. I can still make changes to the payload, but validation is going to fail now because it doesn't have the private key for this, that matches the public key, and that's kind of by design. It shouldn't have the private key. So I can always switch back. I can use some of the other algorithms also. There's the elliptical curve algorithms. I'll have to turn off JWKS URI for that. And then I start getting errors because I've changed things around. But that's kind of a first pass at a new site here for
Cool.
dealing with tokens.
Very cool. Yeah, it's exciting. Um, Good to see more tools like that for debugging stuff.
Yeah.
Maybe I will use that in some of my exercises that I'm doing for my upcoming course.
Yeah, great. So we're at the stage now where we're asking friends like you all to beat it up a little and let us know if you encounter any bits of weirdness. I already have encountered a few, so it's definitely kind of beta right now, and we have issues. Right now, the GitHub repo is private, but in the next week we're going to open it up. It's an open source project, and we'll start putting issues on it so that we can resolve them rapidly. And once the JWT part of the site is very stable, we're gonna then add in the Paceto, and we might even do a little poll to talk about what other token formats we might want to have represented on the site. We actually have the Paceto part of the site kind of in the can, but we just wanted to make sure the JWT was really stable before we added more
Mhm.
complexity with different token formats.
That'll be cool too, because that'll be a good way to play around with those new token formats. Because I haven't played around with them very much yet.
Yeah.
Yeah, cool. So I refreshed my memory about the ISS parameter thing, and I believe I can explain it now. So let me go back to this spec here. Um, and the key thing in here was this sentence. If an attacker can tamper the authorization response before it's received by the client, the attacker would also have access to the authorization code, which means they don't need to do a mix-up attack to steal the authorization code. So the assumption is that this is protecting um, this is protecting the attack when the attacker does not have access to the response. So in your browser extension, you do have access to the authorization code already in the response because it's a browser extension.
Right.
So the attack here is it's a different kind of attack that it's protecting against.
Sure.
So
Yeah. This kind of goes back to some of the feedback I got on my authorization code intercept
mhm,
example, and part of the feedback, which is absolutely true, is if you have a malicious browser extension, you kind of have bigger problems than OAuth anyway. A malicious browser extension could doing anything. It could be capturing your passwords. So that is a fair point, and it makes sense in
yeah.
the context of what this new parameter is trying to solve.
Yeah. So what this is solving though is let's say, for example, you don't have a way to intercept the response, right? What are some ways you could try to get an authorization code? Well, some clients can be dynamically configured, right? Dynamic client registration and dynamic client configuration is a thing, which is why things like this document exists. This is it's like the URL you were just showing of, this is where the keys live, but this metadata URL contains a bunch of information about this server. And it's got things like the authorization endpoint and the token endpoint, which is going to tell the client where to redirect the user and where to send the authorization code to get tokens. So this is a legitimate document. What would happen if I took this, copy and pasted it, made a new document for, can I pop this out? Oh, it didn't paste with formatting. So I'm going to make a new discovery document, and I'm going to change the authorization endpoint to my own authorization server. And, or I guess, no, the token endpoint, right? So
To try to trick it to exchange the code with that token
exactly.
endpoint.
So if I can get the client to use this discovery document, the fake one, because some clients can be dynamically configured, then it's going to get the user, send the user to the real authorization server, and then send the code back to the client. The client's going to then send it to this token endpoint, which then can steal the code and use it, right? So the idea is the ISS parameter would be sent back by the authorization endpoint, which would be this one, which is going to not match the URL that this document was fetched from. Because this, I guess that's the other part here, is that the client should not let a issuer URL here come from a different domain, right? Like I'm going to host this on my own website, evil.app.com, .well known, or whatever. This is the authorization endpoint. So I can't post a document on that URL because that's not under my control. That's under Okta's control. But I can post a document on this website, and then when Okta does redirect back to the app, it's going to contain not this issuer. It's going to contain the ISS of the real OAuth server, and now the client knows that something got mixed up.
Nice.
Yeah.
That makes sense.
So that's the attack it's protecting against, rather than the authorization code injection attack, which is, yes, a problem. It's still a problem. Different class of attacks, though.
Yeah. Nice.
Yep.
So I posted events.oauth.net just to remind people, you've said it many times before that these are open and participation is welcome. What's on deck for the virtual interim meeting that's coming up?
Yeah. So this is the next interim meeting, which is again, the interim meeting is the official, like on the record meeting, and this is going to be to talk about this draft that we were just talking about, the issuer
Right.
identifier draft. I'm guessing that the authors of this are going to ask it to be adopted by the group. That's my assumption, that it's for why it's on the schedule. So again, you can tell it's not adopted yet because this is someone's name in the URL rather than IETF in the URL.
Right.
So that is my assumption, and should be hopefully a quick meeting.
I have a question, just kind of procedural. It may be too nerdy, I don't know, but I'm just curious, like how do you determine priority? There's so many standards and even I assume that something that is adopted would have higher priority over something that has not yet been adopted. But there's so many things that have been adopted. How do you even determine what you're gonna focus on?
who is you in this question?
Well, like everybody that's participating in the process, right? I understand that it's pretty open. Anybody can participate. Let's say that something that had been adopted were super important to me. I thought it was super important. It should be prioritized. Do I just voice that on the mail chain and
Pretty
kind of
much.
go back and forth with
It's all very
other
much
participants?
individual driven. It's
Yeah,
driven by people. There's not like a sort of overarching entity with project managers and 5 layers deep or whatever, right? It's very much individual driven. So the this is why you'll see a lot of these drafts that just kind of expire and then stay expired and don't get picked up again because whoever was writing it didn't feel strongly enough about continuing the work,
right.
and neither did anybody else. So that is so I guess with Depop, for example, there's I would say a relatively small number of people who are like super focused on it, and a lot of people don't care about it because they're already using mutual TLS or whatever, and it's fine, and they don't need this at all, so they don't care. But the people who do care about it are going to continue to bring it up um, on the mailing list, continue to publish new drafts, continue to get it onto the agenda for these interim meetings. I think that's probably the biggest way to like actually make progress on these things in the official capacity is like you put it in front, you email the chairs, you ask for a spot on the schedule, and um, and then that gets it that's how you actually move forward with it. So, but it is very much like if you care about something and you want to see a draft adopted, then you can be the one pushing it forward. If the authors have lost interest, then you have to convince them to care about it again. Or if they really don't, you could ask them to be added as a co-author, right? And like take it over. So
Yeah.
a lot of different ways that can work.
I'm sure that has its own challenges, but I appreciate that as just as a process. It's not driven by some artificial, any overarching kind of procedure. Um, I kind of dig that.
Yeah, it's an interesting way to work. And then so for me, I'm actually like now taking on a lot of these things and almost too many. So I'm having to prioritize my own work with that, right? So I've got this spec for browser-based apps, a recommendation for browser-based apps, which I haven't updated in a while, um, and I need to make progress on that. But I'm also balancing that with the OAuth 2.1 work, which thankfully I have other authors, co-authors on that, and now also the new GNAP work. So it is very much a matter of like, how am I choosing to spend my time that I've dedicated to standards development?
Right.
And it's everyone's playing that game, right? Everyone has got other work they're doing as well, and as part of their jobs at the companies they're in, um, it's there are not many people whose actual full time job is just editing specs in this group.
Right.
Um, it's people work at a company doing something and also help write these specs. Like my main job is doing workshops teaching people about OAuth, and then I also contribute to the specs.
Got it.
Yeah.
Yeah, but I was just looking over the GNAP spec. A lot of interesting stuff going on
Yeah,
all at the same
we
time.
can we can talk about that a little bit too, because that actually was there was the IETF meeting, and that was 2 weeks ago, on the official schedule at the IETF, and we had it was like I think it was like at 9 p.m. or something for me, and poor Justin Richer, who's on the East Coast, it was at like midnight for him,
Oh wow.
um, and he was the one presenting. There was a screenshot I took of the meeting, but this was the since first meeting of this group since the draft has been like rewritten and readopted with the new authors on it. So a little bit of the history on that. There was Justin's original draft called XYZ or transactional authorization, which the website is OAuth at XYZ. And then Dick Hart wrote an alternative called XAuth. And things worked a little bit differently, but it was kind of the same idea of like rethinking the whole thing. So there was this whole process over the summer of this design group that took those two documents and then went through and sort of like found what the project was to find the best of both worlds, of like pull out the best bits of each one and combine them into a new document. And then that became the new starting point for the discussions. So that document was published, and this is the first meeting since then. And that's when myself and Fabian were added as co-authors of that. So, or editors of that. So we are now having regular editors meetings every couple weeks to discuss open issues and try to continue making progress on that new spec. So that is that's what I'm doing right after this. Is I have to go send a couple emails to that list about the meeting we had yesterday, and working through a very long list of open issues on that, which is, let's see. So this is we're officially using GitHub for the development of the spec, which is not true with the OAuth spec. And we also are like making an explicit process for using labels to categorize things. So you'll see, let's see, a bunch of these we talked about yesterday. We are marking them as pending close, which means that we believe the discussion has concluded, but we're not just closing it outright. We're getting, you can see issues will be closed unless there are changes to consensus. So we believe that discussions happened. We want to make sure people have a chance to see that we believe this, and then in a week we'll close the issues, and that'll wrap it up. But 5 pages of issues that we have to figure out.
Nice use of GitHub.
How, yeah, no, I think it's a good way to manage that, because the alternative is all the discussion happens on the mailing list, which is then very hard to follow. Very, very hard.
I have tried.
Yeah.
It's totally doable, but it is more challenging. I'm much more at home in the world of GitHub issues than email threads.
Yeah.
Nice.
So yeah, that's there's some interesting stuff going on there, and I need to now actually try prototyping it myself too, to get a better sense of of how the whole thing works and where I feel are the strong or weak points of it.
And for the memory challenge, such as myself, can you refresh our memories on what it's all about in a nutshell?
Yeah, so that spec, it's in a new ITF group, so not the OAuth group, but it is meant to solve a lot of similar things that OAuth solves. The main motivation for it is that like OAuth is great, it works fine. There's a lot of new work happening in the OAuth world, things like pushed authorization requests, rich authorization requests, a lot of these extensions, which are great, and they're providing new functionality into the OAuth world. The challenge that the OAuth group has in doing any of that work is that it all has to be backwards compatible and build off of the OAuth 2 framework. So there's limited amount of things you can do to like make totally new features. I think rich authorization requests might be one of the biggest new bits of functionality, and it's doing it in a way that like builds on top of OAuth. And then push authorization requests, the idea of starting the flow in the back channel, I guess it's technically a breaking change, but like you can adopt that or you can not adopt it, right? And those are both great for security and new features. But then if you look at how they're written, there's a lot of things they have to do because it's based on OAuth that like might be better designed without that baggage. And it's very much just like an aesthetic, like design decision, right? Like you don't have to have a protocol be pretty for it to be useful. So the idea with GNAP is to um, take all of these use cases that we're now trying to do in OAuth and make sure that the spec can do all of those things as a first-class citizen from the beginning in an elegant way. So that way it's not bogged down by a 12-year-old protocol. And this ends up looking like everything's JSON because we don't need to worry about form encoded posts if we're which OAuth does, or like we can
Bless you
start the
for
flow.
that.
Yeah, we can start the flow in the back channel always so that every flow is consistent rather than in OAuth you kind of, depending on where you're running, you kind of have to start things differently. Like the device flow works from the back channel first, but the redirect flow doesn't. And yeah, it's just a way. It's a the idea is to clean things up, but at the end of the day, it will solve many of the same use cases. So this is also a big question of like, should you go upgrade, right? And probably not. If you have stuff built in OAuth, it's not like it's going to break or suddenly be bad. So the it's more about for new implementations who do want, especially some of the more advanced or complicated functionality, it's supposed to be easier to build that using GNAP than trying to put all the building blocks together in OAuth to make it work.
Neat.
Yep.
So you get a greenfield place to kind of take some of the best learnings of OAuth without being constrained by it
Yep.
to add new
Exactly.
stuff.
And one of my personal goals with it is to make sure that it works in an open web kind of way. So this is actually one of the things I've done with OAuth is write an extension of OAuth called IndieAuth, and that is a way to get rid of the idea of needing pre-registered clients, and it also establishes that user identifiers are part of the spec as a URL, where that URL of the user identifier can also be the way that clients can start the flow. So rather than needing to pre-register client IDs and secrets and having to have apps show a list of all the buttons of all the different providers, a user can go in and just type in their OAuth server into the app itself. The app can then discover all the endpoints and then do the flow without needing to pre-register at the OAuth server. So a good example of this would be like you download an app on your phone to edit your WordPress blog, and your WordPress blog is on your own website, not WordPress.com. Well, that app doesn't have any prior relationship with your website because it can't. So you need to somehow tell it, where is my blog and how do I log in? And up until now, the only real way to do that is by putting in your server URL, putting in your username and password. And that's not good for many reasons. Like, do you trust that app developer with your password? Probably not. Ideally, you would use OAuth to do that. So you have to tell it where is your WordPress site, and then it can do an OAuth flow with your website. And that means that we can't use client registration, so we don't have any client secrets. Everything's a public client, and it means we need to use Pixie, and it works. It works great. So this is that's an extension. It's been around for a long time now, many years, and we're continuing to update it to the latest recommendations from the OAuth group as well. So there's been some changes this year to do things like build Pixie into the spec, the way OAuth 2.1 is doing. And the so my goal with GNAP is to make sure that framework or that way of that architecture can be supported first class rather than having to extend it in order to do that, right? Because if you look at the core OAuth spec, you need to add a bunch of stuff to make that work. So I want to make sure that with GNAP, it's just there and can be used.
Awesome. Makes a lot of sense.
Cool. Well, let's take a look at this last question, and I think wrap up after that. Sound good?
Sounds good.
So for browser-based apps, which are public clients, yep. What are the pros and cons of using refresh tokens versus silent refresh when using authorization code and Pixie? Yeah, that's a good question. So I guess first of all, let's clarify silent refresh. what we mean by that. I'm assuming what we mean by that is you want to keep the user in the single page app without redirecting them away, right? So that you can have the app interface loaded up, it's running, and then it needs to get a new access token, and you want to do that without them leaving that page. So typically the way that works is by dropping in an iframe into the page, which is a link, which is the authorization request that does the authorization code flow, and results in a access token being delivered into that iframe, which can pop it back up into the page. And you'll see like response type form posts and stuff like that because of how it has to work in the iframe. The refresh token method would be if the browser has a refresh token, it can just go make a post request directly. So I guess there's a couple of different considerations here. The silent refresh iframe trick is kind of going to stop working if your token endpoint or if your OAuth server is on a different domain than your app. And that's because of recent changes to how browsers are handling cookies. And they are no longer going to be sending the cookie to the iframe, like in the iframe, if it's embedded on a different domain. So it'll basically just not work anymore. Now, if your application and your OAuth server are on the same domain, I believe subdomains can work in some cases for that too. I forget the exact cookie rules, but if they are on the same domain, that would still work. However, it's very likely that they're not because very few architectures actually have the OAuth server, built in to that system. So in that case, the silent refresh iframe trick is going to stop working, which means you may need to use refresh tokens instead. Because with the refresh token, we do have cross-domain support for post requests, which is cross-origin resource sharing, and that means that your JavaScript code can talk across domain to the token endpoint as long as it's configured properly, because you're not dealing with cookies at that point, right? You're just dealing with a post request containing data. Yeah. Can you think of anything else? Any other differences?
No, just that there is some dependency on the provider that you're using. So Okta, which is the one that I know best, it's kind of put a line in the sand of not giving spa apps refresh tokens ever, even if they're using Pixie, where it
That's
will for a
that's
mobile app.
not true anymore.
Oh, goody.
Yeah. As of I think like this week,
Oh,
you can request. It's in beta still, so you have to like go talk to support to get it enabled on your account. But there's a new feature that will let your single page apps get refresh tokens if you want to enable that. And the JavaScript library has been updated accordingly as well.
oh, neat. Well, that's
Yep.
handy. Yeah.
Yep.
But also, just generally speaking, you need to know your provider to make sure that that's even an option for you, as it wasn't up until maybe this week. This is what happens when I go away
Yeah.
on vacation. But that's pretty cool.
Yeah, it's very cool. It's and I think it got prioritized because of the browser cookie rule changes, kind of going to break all the silent refresh flows. But I guess there are some things to keep in mind there too, because a public client like a JavaScript app with a refresh token, that refresh token is the only thing needed to get new access tokens, and that makes it very powerful because if it can be stolen, the attacker can just use it as long as they want, and there's no way to tell that that's happened. So it is, that's the slightly higher risk there. That's also the reason for the refresh token rotation we talked about at the beginning. And I don't remember if the token rotation is part of the launch this week or if it's just the ability to get refresh tokens at all. So I'm going to take a look at that in a minute because I'm really curious.
Yeah.
But that's one of the ways to limit the risk there of public clients like JavaScript apps having refresh tokens. Yeah, cool. Well, we are at the top of the hour, so I think we'll go ahead and wrap up here. Thank you everybody for joining. It was a lot of fun, and
Thanks. Good to be back with you.
yeah, see you again in. Oh no, we're not doing this in 2 weeks, right? This is the
That's
last
right.
one, I think.
Yeah.
Yeah,
Holiday
because we're
break.
on holiday break after this, so we will be back next year in 2021 in that case, and hopefully there'll be some interesting new developments between now and then in the world of OAuth that we will come back and talk about.
Make sure
So
to promote our next edition properly so you know when it's going to happen.
yeah, exactly. And again, subscribe to us on YouTube or Twitch, wherever you're watching this, so that you get notified of the next one. And check out events.oauth.net because we also post them there. All right. Thank you, everybody. Have a great rest of the day.
Bye now.